It has been an absolutely seismic week in AI with the launch of OpenAI's Operator, the announcement of the $500 billion Stargate project, and the unveiling of China's Deepseek R1 model. We will cover all of those today along with the other latest AI news, so let's get started because there is a lot to unpack. First up, OpenAI announced the launch of Operator, a new AI agent designed to perform tasks for its users. They demoed its ability to book dinner reservations through OpenTable, plan a meal and buy all the relevant ingredients off of Instacart, and organize the booking of tickets to the next Warriors and Lakers game. They explained that it's powered by Kua, their computer-using agent model, which mimics human interactions. Essentially, it interacts with websites and applications just like a human would via keyboard and mouse. It is currently limited to the $200 a month Pro subscription in the US, and it is still prone to glitches and requires frequent user intervention. For example, it cannot bypass CAPTCHAs, and it had a 1% chance of failing to identify malicious websites. They talked a lot about keeping a human in the loop of decision-making while at the same time admitting to it making irreversible mistakes such as sending emails to the wrong person. It has also been programmed to be deceptive, claiming 20 years of experience and feigning ignorance of people it might recognize in photos. It performed significantly better in the benchmarks they showed, still paling compared to human performance, but this is still a revolutionary product, giving us a first look into the world of AI agents and helping us understand why many people are dubbing 2025 the year of the agent. In a couple months, we will all have our own AI agent, leading to huge increases in human productivity, but also potential job displacement. Next up on the docket, the CEOs of OpenAI, Oracle, and SoftBank joined Donald Trump at the White House to introduce Project Stargate, a proposed $500 billion collaboration between them to build advanced AI data centers. For context, this is more than half of the annual cost of the US military and more than the revenues of Facebook and Google for the year combined. During the announcement, they highlighted claims of being able to cure disease, create jobs, and advance AI research, though some found Larry Ellison's comments on using AI for surveillance quite dystopian. Indeed, Dario Amodei, the CEO of Anthropic, was at Davos this week, and during a panel, he commented on how AI has the potential to create a George Orwellian 1984 type society. There was considerable skepticism to the announcement of the Stargate project, with Elon Musk starting a expat claiming that the money did not exist. Sam Altman replied, inviting Elon to visit the areas where they had already broken ground on new data centers. And in an interview, CEO of Microsoft Satya Nadella said, "I am good for my 80 billion." In other news this week, we saw the launch of a Chinese model called Deepseek R1. The model demonstrated exceptional performance against benchmarks, rivaling and sometimes surpassing OpenAI's own models. And yet it was built on NVIDIA's old H800 GPUs, raising questions about the effectiveness of US chip sanctions on companies like NVIDIA, and demonstrating the rapid progress of AI outside of Western tech giants. The model is a chain-of-thought reasoning process using a combination of reinforcement learning and fine-tuning, with an emphasis on rewarding the outcome rather than the individual steps. While the model is open source, the underlying training dataset is not. And unlike with OpenAI, it allows for full transparency of its chain of thought and will, in fact, sometimes reason in different languages. DeepSeek's training method showcases the power of allowing models to learn independently via reinforcement learning, representing a significant advancement in AI development. In other news, Perplexity launched its new assistant, only available on Android, highlighting its capability to summarize web pages and suggest reading material, and generally demonstrating a higher performance than Siri. Overall, it demonstrates the trend of AI assistants moving beyond simple voice commands to become more integrated into our daily tasks. Demis Hassabis, the CEO of Google's DeepMind, sat down for an interview this week, revising his prediction of when we might achieve AGI within 3 to 5 years, and emphasizing his definition of true AGI as being able to invent new scientific hypotheses and theories. To me, the most interesting part of the interview was when he talked about DeepMind's attempts to build a digital replica of a living cell to allow for in silico testing of new medical breakthroughs. I will include a link to the interview in the show notes and the top 3 snippets at the end of this show, so stay tuned. Finally, the New York Times ran an article on humanity's last exam, a benchmark devised by AI researchers to be the hardest ever for AI. Indeed, amongst current models, the top score is only 8.3%. The article emphasizes that we are running out of benchmarks to run, and that we might need to measure progress with more than just tests, but rather with economic impact or ability to make new discoveries. If you found this content enlightening, please hit the like button and subscribe for a succinct weekly lowdown on top AI news. Now to 3 fascinating moments from the Demis Hassabis interview.
Everyone's lips right now, and the debate is how close are we to AGI? What's the correct definition of AGI? We've sort of had a consistent view about AGI being a system that's capable of exhibiting all the cognitive capabilities humans can. But I think we're still probably a handful of years away. And I think one thing that's clearly missing, and I always had as a benchmark for AGI, was the ability for these systems to invent their own hypotheses or conjectures about science, not just prove existing ones. So of course that's extremely useful already, to prove an existing maths conjecture or something like that, or play a game of Go to a world champion level. But could a system invent Go? Could it come up with a new Riemann hypothesis? Or could it come up with relativity back in the days that Einstein did it with the information that he had? And I think today's systems are still pretty far away from having that kind of creative, inventive capability. I mean, I would say that AI research today is overestimated in the short term. I think probably a bit overhyped at this point, but still underappreciated and very underrated about what it's going to do in the medium to long term. And I think part of the reason is these systems are still fairly brittle, partly because they are quite flawed still, and they're not AGIs, and you have to be quite specific, for example, with your prompts, or you need there's quite a lot of skill there in coaching or guiding these systems to be useful and to stick to the areas they're good at. And a true AGI system shouldn't be that difficult to coax. It should be much more straightforward, just like talking to another human. So if you think about what we did with AlphaFold, was essentially solve the problem of the finding the structure of a protein. Proteins, everything in life depends on proteins, right? Everything in your body. So that's the kind of static picture of a protein. But the thing about biology is really you only understand what's going on in biology if you understand the dynamics and the interactions between the different things in a cell. And so a virtual cell project is about building a simulation, an AI simulation of a full working cell. I'd probably start with something like a yeast cell because of the simplicity of the yeast organism. And you have to build up there. So the next step is with AlphaFold 3, for example, we started doing pairwise interactions between proteins and ligands and proteins and DNA, proteins and RNA. And then the next step would be modeling a whole pathway, maybe a cancer pathway or something like that would be helpful for solving a disease. And then finally, a whole cell. And the reason that's important is you would be able to make hypotheses and test those hypotheses about making some change, some nutrient change, or injecting a drug into the cell, and then seeing what happens to how the cell responds. And at the moment, of course, you have to do that painstakingly in a wet lab. But imagine if you could do it 1,000, 1,000,000 times faster in silico first, and only at the last step do you do a validation in the wet lab. So instead of doing the search in the wet lab, which is millions of times more expensive and time consuming than the validation step, you just do the search part in silico.
Dream materials for you to find in that set of new materials.
I dream of one day discovering a room temperature superconductor.
So what will that do? Because that's another big meme that people talk about.
Well,
so
then
what do you?
Well, it would help with the energy crisis and climate crisis, because if you had sort of cheap superconductors, then you can transport energy from one place to another without any loss of that energy, right? So you could potentially put solar panels in the Sahara Desert and then just have the superconductor, funneling that into Europe where it's needed. So I think it's would be one of the most impactful technologies ever, is to basically have in silico design of materials. So we've done step 1 of that, where we showed we can come up with new stable materials, but we need a way of testing the properties of those materials.
Right.
Because no lab can test 200,000, tens of thousands of materials or millions of materials.
Are you impressed with what China's up to? I mean, Deepseek is this new model getting?
Yeah, it's impressive. It's a little bit unclear how much they relied on Western systems to do that, both training data, there's some rumors about that, and also maybe using some of the open source models as a starting point. But look, it's impressive what they've been able to do. I think that's something we're going to have to think about, how to keep the Western frontier models in the lead. I think they still are at the moment, but,
right.
For sure, China is very, very capable at engineering and scaling.